Okay. So when you're dealing with angles on the unit circle, which I'm going to give you a picture of in a second, actually a PDF file. So starting today, I want you to have that PDF file open at all times because I'm not going to force you to memorize a circle, so you need to have it handy. All right, and I'll post that in a minute. I also sent you all of Chapter 7 notes from the book that I thought were important, but it's also in your book, so it doesn't matter. But just so you have them, it's there. Okay, so this is the initial side. So when an angle starts here at rest, is going to be 0. So whenever I move in this direction, so imagine this angle, we'll call it theta. If it goes from here and then shifts to there, that's considered to be positive. So going in the counterclockwise direction, right? That's positive. This would be, and then wherever you stop, we call that the terminal side. Okay. So right here, I make a note. This is a positive angle. This is counterclockwise. All right. Now going the other direction would be negative, right? So if you have the starting point here, and it shifts down this direction, so this theta is going that way. So this is my initial side still. Terminal. We'll consider this to be a negative angle, okay? And I'll give you some pictures very soon. Negative angle. Okay. Can you guys see this, or is this a good angle for you? Okay. Just let me know if it's ever blurry, because sometimes I need to adjust. So I know it's counterintuitive, but clockwise is negative. Okay. Now, the quadrants. So the homework is going to refer to different quadrants for the angles themselves. So pretty much it's the same x and y plane. It's just that this is still the first quadrant, second quadrant. So it goes backwards. Fourth quadrant. Okay. So right here, x and y are positive, right? So I'm going to make a little comma face there. X positive, y positive. You see what I mean? X and y. So this is a coordinate. Over here, x is negative, y is positive. Over here, they are both negative. So this will help you, when we start using the circle, or, make things a little simple. Over here, we have plus negative. Okay. All right. Let me send you that file. Oops, there's some guy waiting in the waiting room. Do you guys get the files I sent you, right?
I did.
All right.
Yeah.
Yes, sir. Yes, sir.
All right.
Yeah.
So save this one. I'm going to throw it in the chat box. Try to have this one open at all times, okay? And I'm going to open it during lecture too, but this is a little easier. It's easier if you have it in front of you. Okay, so this is the starting position. This is my initial side here. So if I shift the angle this direction, it's going to be 30 degrees, meaning positive, right? But if I start here but go this way, that is a negative 30 degrees. If I go all the way around and land at the same spot, that's 330 degrees because I went the positive direction, counterclockwise. So depending on how you get there, the angle would be considered positive or negative. If I go this way, positive. If I go this way, negative. Even though that is the same angle, it is considered to be positive or negative. Does that make sense? Okay, so this is the first quadrant that I was drawing on the paper, both positive. This one was negative. positive, negative, negative, and positive, negative, right? Okay, let's get back to the example, or the notes first, then examples. Not quite. Okay, so this is the quadrants of XY plane. So just like in college algebra, right, when you draw parabolas and stuff, this is still X and Y. It's not anything new. It's just that we're going to be using it as a to reference angles now. All right. All right, here we go. So here's a note. This is going to be very handy for your homework. So one counter clockwise revolution is equal to 360 degrees. 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. So we're going to do a couple examples when they use the degrees, meter, seconds. Um, so we will use this. We refer to this as degrees, meters, seconds. So what they're going to do is they're going to give you like, let me see, I have an example here. So they're going to give you something in this form, degrees, meters, minutes, seconds, and you got to change it back into just a simple degrees using these conversions. Okay, and we'll do a couple of those probably in a second. But I want to give you all the formulas and then ideas first. Okay. Let's mention the arc length that's going to come up in a bit. So for a circle of radius I would just call it R, a central angle of theta radians subtends an arc whose length is S equal to R theta. So you're going to be using this formula when they ask you, what is the arc length of an angle that's swept across the unit circle? So basically, give you a preview here. So basically, what they mean by arc length, so let's say you're right here at the 0, and you travel over here, right? So what is that length? The length of this curve is what S is talking about. So you need to be given a radius, and this is a unit circle, meaning it's a radius 1, a unit 1 circle, right? So R would be 1 here. But if they ask you what is the arc length of, I don't know, I sweep across all the way over here, and I have a radius of 2, so this circle is twice as big. What is the distance traveled around the circle? That's what arc length means, okay? And we'll do examples of that in a moment. Okay.
Professor,
Mm-hmm.
what is the word? It says sub something,
Where? Sorry.
arc length, radius, sub.
Subtends, meaning when I sweep across like this is subtending.
Subtends. Okay.
Mm-hmm. Yeah, it's a weird word. So yeah, it's just sweeping across. So basically, like if you had a you remember those compasses back in grade school? You draw like a circle or whatever. So that compass goes out a certain radius, right? Goes out, and then you sweep across. That line that you draw would be the uh, your S arc length.
Okay.
And so you're subtending that angle, I guess. Anyway, let me give you some more formulas. One revolution. I like to have everything, all the formulas ready before we start examples. That way I know what we need. One revolution is equal to 2 pi radians. So degrees is kind of a made up unit. An actual unit that we use in like physics or engineering or the real world, right? We prefer the radians, which is going to be the pi over 6, pi over 4. So they're like fractions of a circle because that's the angle, right? So degrees are easy to use because that's what we're used to. And these are fractions, which people hate. But when you're calculating distances or revolutions or whatever, you need to use the actual unit because degrees is kind of meaningless. So you'd have to convert or use this one if you're not given this. Okay. So let me give you the formula. So the definition, 2 pi radians, meaning 360 degrees is the same as 2 pi. So in radians, going around one time is 2 pi. 180 degrees, which is a complete turn, right? We all know that. That's equal to pi radians. 1 degree is equal to pi over 180 degrees. 1 rad or 1 radian is equal to 180 degrees over pi.
Is this is it radius or radian?
Radians. IANS. Yeah, it does look like a U, right? Sorry. Okay. Now, one more formula, and I think we can start a bunch of examples. So, area of a sector. Okay. Yeah, I'll just leave it there. It's whatever. The area A of the sector of a circle of radius r formed by a central angle of theta radian. So we use the lowercase theta, Greek letter, for angles almost all the time for this class, okay? So if you ever see this, 90% of the time, if not more, they mean some sort of angle, okay? Sometimes we use alpha and beta, but this is the most famous one. Most popular is probably a better word. Okay.
What is that? A portion? The last sentence,
So the area A of the sector of a circle of radius r formed by a central angle of theta radians
okay, thank you.
is going to be this guy. And all that we're saying here, right, to keep it simple, because I feel like math books like to make things sound complicated. But once you see the idea, it's like, well, that's not hard at all, right? This formula gives you it basically gives you the area of a slice of pie. So if you get a circle, you get a like picture of pizza, right? You grab a slice. What's the area of that slice? Well, it's given to you by this guy. That's all it is. Does that make sense? Nothing crazy. All right. All right. Is it okay if I turn the page, or I'm gonna wait a bit? There's no rush here. Do you guys have any questions so far?
That does say sector of a circle of radius, correct? Not radians.
Right. This time it is radius.
Okay, just making sure. Thank you.
Yeah. Opening a soda, right? It's not no beers right now.
Is there a difference with radius and radians?
Radian is a unit. Radius is a here. Let me show you. Radians is used as a measurement for an angle, right? So 30 degrees is how far you went from here, right? If I do a complete flip, that's 180. So a radian is the representation of these degrees right here. So pi is the same as 180 degrees. So pi radians, 5 pi 6 radians means 150. Pi over 2 means 90 degrees. So that's what we mean by radians. It's the measurement of the angles, or the distance we went across this circle. Okay. Well, sorry, not distance, the angle that we made by sweeping across. Distance would be s technically. And radius is just how big is the circle, right? From the center out, that's a radius. So they're very different. Okay, and I'll post these as well as soon as possible. Now let's start some examples, and I'll keep referring to those formulas. Okay, so the first thing you need to learn is how do I convert from degrees to radians, right? So example 1. So the first few homework questions will be like some basic theory questions, and then they'll start with convert the angle in degrees to radians. We're going to use the 45-degree angle. So if you look at the circle, you already know the answer, but that's not the point. The point is learning how to convert it and show on your work. Because, I mean, check it out. It's on the circle. 45 is right here, which is equal to pi fourths. So we better get pi fourths when we do our work. Okay. So the way I want you to do it, like on an exam or whatever, is to multiply by the conversion factor. Remember how we said that 1 radian is equal to pi over 180. So what you need to use are these conversion factors. I'm going to write them right here. So for degrees to radians, use this guy here. Put the degrees on the bottom. Radians to degrees, use the inverse or the reciprocal. 180 degrees over pi. So since I am going from degrees to radians, multiply by pi over 180. And the reason it's on the bottom is because I want to cancel the degrees. So no longer in degrees, now I have 45 pi over 180 radians. But of course we need to simplify that because it's improper fraction, right? So divide divide by 15, right? Let's see here. Yeah. Actually, 45 would work. So technically, using the way we used to reduce fractions is to factor it. That way we know it's good, right? I know we don't, some of you might not do that. You just try to figure out what's the biggest number to divide by. But if we do it this way, we know for sure that I'm done. So 45 times 4 is 180 degrees, right? So 45s will cancel, leaving me with the answer that we already knew. Correct? Okay. Is there any question on example 1? Sorry, people keep distracting me. Not you guys, but people over here. Okay. So it's not too bad, right?
Mm-mm. I don't think so.
So let's do the other direction, then we'll move on to something harder. Okay, so convert, oops, the angle. Yeah, man, writing all stupid today. To a, let me see, how should I phrase it? Convert the angle to, we'll say degrees, I guess. So pi over 2. We know the answer is 90 degrees. That's not the point. Point is to convert it because sometimes these will be ugly numbers or they won't be on the circle. They're not always on the circle. So you have to know how to convert it. And you got to show your work. So I'm going to use this guy to cancel the pi and be left with degrees. That's kind of how I remember which one to use, is because whatever's on the bottom will cancel with the top part, right? Because that's how fractions work. So if I want to get rid of the degree symbol, I better have degrees down here. If I want to get rid of pi stuff, well, I better have a pi on the bottom. So here is so that will cancel, leaving you with 180 degrees over 2, which is, of course, the answer we already knew. Are there any questions about that?
So far, so good.
Pretty simple.
Mm-hmm.
Cool. That's good. I like to hear that. Okay. Example 3 then. This time, this is gonna, so the homework will start off with questions like this. Their numbers might be uglier, it might be similar, who cares? But same type of question. Then they're gonna move on to converting. Let's see, where is that? Oh, here it is. Convert the angle to a decimal. So this one's kind of weird. And to be honest, I rarely use this, so I'll forgive you if you forget this example after the class ends. Because it's, I think, mainly used in like, what's the word? Nautical type stuff, like sailing. So anyway, if you're not in the Navy, it's probably not a big deal. So 36 degrees, 13 minutes, 56 seconds. So convert this into a decimal, meaning just degrees. None of this weird minute second stuff. So what you, the process, I mean, the work is not hard. It's just you have to learn the process because it's a little strange. So I'm gonna write some notes so I don't forget that 1 minute is equal to 1 over 60 degrees, and 1 second is 1 over, well, you guys know that, right? How many seconds in a minute? Or an hour?
60.
60.
So
3600.
yeah, 3,600 an hour, 60 in a minute, right? So we're going to use this guy for the conversion. Okay. So we're going from minutes to degrees, seconds to degrees. So this is what you do. So you rewrite the question as 36 degrees plus 13 minutes plus 56 seconds. Because really, that's really what it means. Like, do you remember how, well, I guess you probably still use that. Like on the ruler, we have 3.5 inches or 3 2/4. When we say and 2/4, that means plus, right? 3.5 means 3 plus 1/2 inches, etc. Same thing here. 36 degrees, 13 minutes, 56 seconds is the same deal. You're just adding them. So we're going to convert these separately and then add it to the original, and we'll have our answer. So just convert this. Okay. So what you do, let's see here. What you do is remember that this is 13 times 1 minute, right? You agree that's the same thing? The number 13 times a minute is 13 minutes. I know that sounds silly, but it's important. 56 times 1 second, you agree that's 56 seconds, right? Okay. So now use the conversions that I wrote here, and you'll be good. Now we just got to add numbers or use a calculator, really. So this will be 13 times 1/60 degrees plus 56 times 1/3600 degrees. Okay. So now we need our calculator. What is 13 divided by 60? I don't know what that is. Where's my calculator at? Okay. It's like 0.2
Yeah,
something
you're
something.
gonna have to round. Yeah, 0.2166667, something like that.
Okay. So 36 degrees plus 0.21666. Let's round it off here. 7. Plus this guy is 56 divided by 3600. That will be 0.0155. Now, if you're wondering, like, how do I know where to round, right? They're going to tell you in the problem how far to go. So I'm choosing to cut it off here. I think when I wrote this question, I think they said 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I think the final answer needs to have 2 decimal places. So add these guys up and then round to 2. So that would be what? Yeah, so 36.23 degrees. So that is the angle, no minutes or seconds. Okay. Is there any questions on what we did? I need a little steps in between.
The symbols, these symbols up on top, underneath the word decimal right there on that top little area.
Yes, here.
Yeah. That's a minute equals 1/60 seconds.
60 degrees.
60 degrees. Okay, my fault. Yeah, okay, I got you. And then the 1 second equals 1/3600 minutes.
Degrees. It's degrees
Degrees.
as well.
Degrees as well. Okay.
Yeah, we're going to use that as our
That's right. Okay.
formula.
I got you now. That makes total sense to me now. Okay.
Okay, cool.
Cool.
Yeah, I mean, there's some in between on how to derive them, but if you write this down, you don't have to worry about it. Okay. Now let's go the other direction. The other direction is a little bit harder, going from this to minutes and seconds. Okay. But let's do it. Guys, have any questions on number 3 before we move on?
How did we get 36.23? Were we rounding?
Yeah, they have to tell you in the homework. They'll say round to 2 decimal places. So just add these guys up and then round 2 decimals. That's it.
Okay, gotcha. Oh, we're not rounding before we add. We're adding and then rounding. Okay, got it.
Yeah,
Sorry,
round you always round the very end unless they specify otherwise. So like it would probably be better to add them as fractions. If you don't, then you got to have enough digits to ensure accuracy. Because once you start rounding, you're losing accuracy. Okay. All right, let's do it the other direction. Example 4. Convert the angle. Oops, somebody's trying to get into class. Let me fix that. Convert the angle to degrees, minutes, seconds. That's supposed to be a degree symbol. All right, so 53.694 degrees. So go the other direction, right? And I'm going to make a note here. 1 degree is 60 minutes. And 1 minute is 60 seconds. Okay. So this is what you're going to do. You're going to kind of cut off the decimal part and work on that separately. Because this thing isn't really doing anything for us. We don't have to worry about the 53 because it's already in degrees. That's the first part, right? The D part. So we'll work on this guy. 0.694. So you agree that this is the same, these two, right? So then let's work on that 6.94. Okay, 1 second. 694 times. Yeah, that's what it is. Okay. So what you're going to do, basically, I'm going to ignore that degree, 53 degrees the whole time. And you're going to multiply 0.694 times 60 minutes. Which will give us what? 41.64 minutes, right? So then you work on the 0.64 and change that to seconds. See what we're doing, right? We work with a degree decimal, change the degree stuff to minutes, and then change this decimal to seconds. So here we go. 53 degrees plus 41 minutes plus 0.64 minutes. So I'm separating that piece off. So you multiply this guy by 60. What's that going to be?
38.4.
Yeah, that's right. So now we have 53 degrees, 41 minutes, plus, you said it was 38.4, right? Seconds. So at this point, you just stop and say, you know what, I don't need this little decimal part. Just cut it off. So the final answer, I'll put it up here, I guess, will be 53 degrees, 41 minutes, 38 seconds.
So we have a 0.4. If it goes over, like, let's say 0.5, we'll do round to 39.
Yeah. Yeah,
Okay, thank
you
you.
just round up. That's right. Good question. Okay. Now let's do 2 more examples and we'll take a break. That'll be the end for 7-1. Okay, example 5. So after you do a couple of these types of problems on the homework, degrees, meters, seconds, backwards and forwards, you will then start asking you like some basic word problems, nothing crazy, I promise. Just find the length S of the arc of a circle of radius 75 meters, I guess, subtended by the central angle 30 degrees. So basically the visual is this, right? So we go out 75 meters and we sweep across 30 degrees. What is this distance that we went across? That's what they want to know. This distance is called S. So as we wrote that formula earlier, remember we said S is equal to, I think it was R theta, right? But what was the requirement for theta? Do you remember? It's an ugly theta, but whatever.
It's going to be radians. So I guess we have to convert 30 degrees to radians.
Yeah, you gotta convert it. So let's do some quick maths over here. Multiply by pi over 180, right? Degrees on the bottom, giving us 30 degrees pi over 180, which reduces to zeros cancel. 3 over 18 is 1/6, so pi 6. So we're going to use this number. So S would be 75 times pi 6. And at that point, just use your calculator because they're going to want a decimal for word problems. Yeah, it looks like 39.2, I don't know, we'll run to 27, I guess, meters. Are there any questions on number 5?
Wouldn't it be 30 divided by 180?
Yeah, 30 divided by 180. That's correct.
Not 180 divided by 30?
Yeah, that's what we wrote, right? 30 divided by 180.
Okay, thanks.
Right? 30 cancels out, leaving you with pi over 6. Just 30 goes into 186 times. Does that make sense, or is that weird?
No, that makes sense.
Okay, so one more time. So on the left-hand side, S equals radius, or that's one part of solving the problem, but the 30 degrees.
Oh yeah, this right here was a conversion.
Oh, okay.
That's separate. This is what we want us to do, right here.
Okay.
But we can't use the formula because the angle theta must be in radians. They gave us an angle in degrees.
So we needed to convert theta.
Yeah.
Okay, thank you.
What's the symbol by the 39.27 stand for again?
The symbol by the where?
At the end of 39.27, is that?
Oh, meters.
Meters, okay.
Yeah, little m is usually meters. Any questions about number 5? Okay, so now we'll do an example for area and then we'll take a break.
I'm sorry, real quick. Where did the 75 come from again?
That's from the question. So remember, this is what we're doing, right?
Oh, okay.
They have a circle or a radius that goes out 75. So imagine you have like some really long rope and then they sweep across some distance. They go 30 degrees sweep, right? And they want to know, okay, well, how far did you go, right? If you go out 75 meters and then walk at this angle, what is the distance S? That's what this is.
Okay. Thank you.
All right, number 2 or 6, find the length S and area A. Okay. So on this one, I think they give us a picture. At least sometimes they do. And say, okay, what is this? What is the area of the sector? The slice of pizza here. Well, they have to give you a radius. So we'll say that this radius right here is 2 feet. The angle is pi over 4. The area, so they want to find the length S. So they want us to do S and area A. Okay. So S is equal to r theta, which is equal to 2 feet times the angle. This one's in radians, so we don't have to do any conversions. Just punch that into our machine. That would be pi over 2, which is 1.5 something. Let me see. Yeah, 7. Okay. All right. So that would be S, right? This part. Now the area is this formula we wrote earlier, 1/2 r squared theta. So that will be 1/2 times r, feet squared times pi over 4. Now that I'm squaring feet, we'll have area, right? Feet squared, or square feet. So this would be 1/2 times 4 feet squared times pi over 4. So that is approximately calculator time. I don't know. Actually, it turns out to be the same. That's funny. Except these are squared units. Oh, weird. Okay. All right, we're all familiar with the difference between feet and feet squared, right? Is that weird, or do you see why? Do you know why these are different?
No.
So feet, like if, for example, if you said you are 6 feet tall, right? That is a one-dimensional measurement, right? Just going upward. If I said your house is 2,000 square feet, well, we're talking about the area of the floor, right? So it's a two-dimensional measurement. That's the difference. 2 dimensions, 1 dimension. You guys have any questions? If not, we'll take a break for about 15 minutes.
Why did we take the squared from outside the 2 feet parentheses into the 4 foot square?
So we squared 2 feet, becoming 4 feet squared. So square the 2 is 4, square the feet is feet squared.
Okay, makes sense.
So the 2 is only on the feet at this point, or the exponent. All right, so definition of trigonometric functions of acute angles. Whatever. So the 6 ratios of the lengths of a right triangle are called trig functions. Okay, so basically, the function sine of some angle theta is going to be written as sine theta equals, or defined as, opposite over the hypotenuse. Cosine of theta is cosine theta would be equal to adjacent over hypotenuse. Tangent, I wrote that weird, but just the word tangent, of an angle theta is written as tan theta equal to opposite over adjacent. Adjacent. So this is the opposite side. This is the adjacent side. This is the hypotenuse. Let me write that a little better. So when we say opposite adjacent, we're referring to the angle that we drew. So there's angle. Opposite adjacent. Right, adjacent meaning right next to it, opposite meaning the opposite side, and of course hypotenuse is always the hypotenuse. Okay, and the common way to remember this is SOHCAHTOA. SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA, tangent, is opposite over adjacent. I'm not saying you have to memorize this, but if you forget or don't have your notes, this helps me remember anyway. Okay. Now there's reciprocals of the original 3 functions that forms the other 3, the total of 6 functions. So cosecant of theta is equal to hypotenuse over opposite secant of theta is equal to hypotenuse over adjacent cotangent of theta is equal to adjacent over opposite. So basically, you take the original 3 and you flip them over. That's it. Take a reciprocal.
What letters? So the last thing you wrote.
Here?
And the above?
This is adjacent.
No. Okay, to the left.
Oh, this right here? Cotangent?
And then up.
Oh, this is, I see. Yeah, I wrote it kind of weird, huh? Let me fix that. It's a CSC, cosecant. So CSC theta. It's cosecant of theta, which means the reciprocal. Okay. Over here, I went ahead and wrote the names out, but the shorthand is sine for this guy. Cosine is just COS. Tangent is tangent, the TAN. Cosecant is CSC. Secant is SEC. Cotangent is COT. And here are the identities.
And that's hypotenuse over opposite, hypotenuse adjacent, adjacent opposite.
Right, right. Okay. Cosecant theta is equal to 1 over sine theta. Secant theta is equal to 1 over cosine. Cotangent theta is equal to 1 over tangent. So they're just a reciprocal of the original 3. That's all it is. Quotient quotient identities. Is tangent theta equal to sine theta over
Will you please lift
cosine.
up the paper?
Oh, thank you. Yes, there it is. So tangent is defined as a ratio of sine over cosine, or opposite over adjacent. It is technically both. Cotangent is equal to cosine theta over sine theta. Okay, so that's all the formulas and definitions that we need. Oh no, actually that's not true. One more. Some of the most important ones. Okay. You guys okay if I turn the page?
Sorry, I'm still taking some notes. Sorry.
Yeah, there's no rush. Just let me know. I'll wait a bit.
Cool. Thank you.
And real quick, what does COT theta stand for?
Cotangent of theta.
Oh, cotangent. Okay.
Yeah, so it's like, if I write, this is cosecant. This is cotangent. And then this is, of course, secant. Okay. Any other questions before I move on to the next set of identities? Okay, then let's go to the next part. Okay, these are the Pythagorean identities. These are going to come up a lot. Pythagorean identities. Okay, so these are the original three that you need. Sine squared theta plus cosine squared theta is equal to 1. It's the most important one because you can derive all 9 of them using this one. Okay, so what you can do is basically subtract the cosine over, and then I have a new formula. Sine squared is equal to 1 minus cosine by subtracting cosine to the right-hand side. Well, on both sides, technically. Now, if I were to subtract sine over there, you'd have cosine squared theta equal to 1 minus sine squared theta. So see how we've made 3 formulas, or 2 more formulas using the original. Okay. Now, if you start dividing things, you'll create more formulas. So if I were to divide the first one by sine, you agree, or sine squared, you agree that sine squared divided by sine squared will be 1, right? Cosine squared divided by sine squared will be cotangent squared. And you don't have to derive them. I'm just showing you where they come from. I recommend you put these all 9 of these on a note card. Okay, and then the next one is it's basically you just move these around and then you get 2 more. So if I subtract cotangent, I get cosecant squared theta minus cotangent squared theta. If I were to subtract the 1 over, I'd have cotangent squared theta equal to cosecant squared theta minus 1. So that's 6 so far. Now, if I were to take the original and divide by cosine, so I'm going to write a note here. Divide original by sine. That's where these came from. Okay. Because if I take this guy here, divide by sine squared, divide this one by sine squared, divide the 1 by sine squared, that gives you 1 plus cotangent plus cosecant. That's where these came from. You came from this. Now divide the original by cosine and you're going to get this. Tangent squared theta plus 1 equal to secant squared theta. Now move that stuff around and you can create 2 more formulas. So if I subtract the 1 over, I get tangent squared theta equal to secant squared theta minus 1. Now if I subtract the tangent, I get 1 equal to secant squared theta. If I subtract the tangent, yeah. So I have my divide the original by cosine squared theta. That's where these 3 came from. By original, I mean this guy. I'm going to put a star on the original. Okay. So that's all the formulas. Yeah, what's
what
up?
is that? What does that say? Right where you wrote that. So tan squared, like the equals.
Here?
Yes. Like
There's
what is that?
Tangent squared theta equals secant squared theta minus 1.
Okay.
Yeah, it's just a little bit hard to tell between like your E's and C's.
Oh, and yeah, that's true. Just remember, SEC is always going to be the same. It's not going to change. So secant, sine and secant look very different. Those are the only ones that start with S, right? But yeah, I'll work on that. Okay. So find the value of the 6 trig functions. So it starts off kind of straightforward. And they give you a triangle. So 6 trig functions of the angle theta in this figure. So this is similar to your homework. It starts off something like this. And they say, all right, well, here's the measurements. Write all the 6 trig functions using this triangle. But if they did not give you the hypotenuse, how would you find it? What would you do? Sometimes they give you missing pieces.
A squared plus B squared equals C squared.
Yeah, right. We've done this before. We can make sure we use it again. So we'd have 9 squared plus 40 squared equals 2 c squared, which implies that c is equal to the square root of 9 squared plus 40 squared. What is that going to be? And that's 41, right? Which we had earlier. Okay. But anyway, if they give us an incomplete triangle, you can find the missing pieces and then you can answer the question. They want the 6 trig functions. They want sine, cosine, tangent, cosecant, secant, cotangent. So sine of theta, we know that's going to be opposite, right? Over hypotenuse, which is going to be, so here's the angle. Opposite over hypotenuse. So 40 over 41. And that's it. Now we go to cosine. That is equal to adjacent over hypotenuse. So what is the adjacent side to the angle? Right? So one right next to it. So 9 over hypotenuse. Okay. Tangent theta is equal to, we'll write it over here. Tangent theta is equal to opposite over adjacent, which is equal to 40 over 9. Okay. Alrighty. All right, next one. Cosecant of theta is equal to, what is cosecant? All right, so reciprocal of sine, so you're going to flip this guy over. Okay. So hypotenuse and opposite. Okay. And then secant theta. That is what? Defined as reciprocal.
Hypotenuse over adjacent.
Yeah, the reciprocal of cosine, right? So hypotenuse over adjacent, which is just flipping this guy over. Yes. Last one, cotangent. Notice code.
Over opposite.
Yeah, adjacent over opposite. Okay, so adjacent is the one next to it, so 9 over the opposite, 40. So those are the 6 trig functions. So whenever they say find all 6 given a triangle, well, they mean this, the ratios. Okay. We're almost out of time here. Let me see what we can do next. Yeah, let's do a different example. Okay. So in this next one, they're going to say, you know what, here's secant. Find they'll give you like one of their functions, and you got to find the other 2 or 3, or maybe all 6, depending. So I'm going to make up the example here. So you're given secant theta, SEC theta, equal to 12. Find sine theta, cosine theta, tangent theta. So secant is defined as
It's not in focus.
oh yeah, you're right.
Thank you.
So what is secant?
Opposite over hypotenuse.
Opposite. That would be sine.
Hypotenuse over adjacent.
Close. It's going to be the reciprocal of cosine. So adjacent over hypotenuse would be flipped over. So hypotenuse over adjacent. Right? So we don't have a number down there. So remember, there's always an invisible 1. Right? Okay. So let's build our triangle. So hypotenuse is 12. Adjacent is 1. So find this missing side. So a squared plus b squared equals c squared. We'll say that this is b, I guess. And c is 12. Right? I feel like I wrote kind of small there. Okay. So then Then becomes a squared plus 1 equal to 144. Subtract the 1, and that becomes a squared equal to 143, which means that a is the square root of 143. So that's the missing side, right? So now that I have that, I should be able to find the sine, cosine, tangent. So sine is opposite over hypotenuse, right? So that would be angles right there, so opposite over the hypotenuse, 12. Cosine theta is adjacent over hypotenuse, so the adjacent side right next to it, over hypotenuse. Finally, tangent is opposite over adjacent, so simply 143.
Jack, for secant of theta, like how it says hypotenuse over adjacent, like that's because we have like 12, so we're just saying like 12 over 1.
Yeah, because there's always a 1 down there. And
Okay.
since it needs to be a ratio, because all trig functions are ratios, you have to put the 1.
Okay, gotcha.
Okay. I think we'll have to stop here. Do you guys have any questions from your homework or from today's examples? Maybe something you missed along the way or you thought was confusing?
This is all considered review, right?
No.
Okay.
Do you mind putting up the lecture slide from, or like the video from last class?
Oh, is it not up? Okay,
No.
I will do so. Yes.
Okay.
I'll do that actually right away then, if it's not up.
So the only thing that's due tomorrow is just the, it's just one assignment that's due tomorrow?
I believe so. It's just the, what's it called? Partial fractions, right?
Yeah.
Right, it's like 9 questions or something like that?
Yeah.
Okay, just making sure. My other classes has like 5 assignments due at the end of the weekend, so I was just like freaking out that this was just 1.
I mean, I should put 3, but I don't want to do
No,
that.
that's
No.
No. Technically, it's supposed to be 3, but I'm not going to do that. Since we're stopping on 7-2, I'll put 7, 1, 2, and 3 for next week.
okay.
But I really want you to for sure be done with, what's it called?
Partial fraction.
Yeah. And technically they stay, I mean, so I set it up so even though it's late, you can still work on it. Okay. There's no penalty. It's more of a guide suggestion. All right.
Okay.
That doesn't mean wait till the last, don't do 100 homework assignments on the last day. That means stay on task, right?
Yes, sir. Well, thank you.
I guess if you have no questions, you're welcome to head out and I'll post that video as soon as possible.
Okay. Have a good weekend, everybody.
Thank you. Have a good one.
Y'all have a good one.
You too.
Bye, everybody.
Let's see. Yes.
Hey, so real quick, just real quick. I was just a little bit behind, but I just want to make sure I understood this correctly. I think I do. But
Mhm.
the question on the second example, on the one you have right here on the screen, the question started off with just given secant of theta equals 12, and then that was the question itself, right?
Yeah, just this top part. That's all you're given.
Okay.
That first line. So
Yeah.
using secant, you're able to create the triangle using secant, and then you use Pythagorean to find the missing piece. And once you have a full triangle, you can find sine, cosine, tangent.
So being that secant of theta is 12, we know that the hypotenuse. I mean, we go with the hypotenuse being. I mean, we know the formula for the secant, so we use that as a whole number, like 12 over 1, and that's just how
Yes.
we.
Yeah, whenever there's a whole number, just put a 1 down there. Should be-
Awesome. Okay, just want to make sure I got you correctly. Okay, cool.
Yeah.
All right, then I think I should be good. I appreciate you very much. I will see y'all next week.
All right.
Thank
Sounds good, man. Take care.
You too. Bye.